Ports are the lifelines of our economies, moving 80% of global trade. But they are also hotspots for emissions, waste, and habitat destruction, while facing climate risks and other threats. The challenge is urgent, but it's also an opportunity to transform ports into hubs of innovation, efficiency, and resilience. Today, we're joined by experts who will inspire us with practical strategies and success stories on shaping green and resilient ports that cut emissions, improve air quality, and drive sustainable, future-ready growth across Southeast Asia. The webinar begins shortly. Please stay tuned.
Hi everyone, and welcome to today's Greenport webinar. Really excited to have you all join us again. Today we're going to be focusing on dry bulk cargo ports. Dry bulk cargo ports play a critical role in global supply chains handling commodities that underpin energy systems, food security, and industrial production. However, the very nature of bulk handling, open stockpiles, conveyor systems, shiploading, and high-volume truck and rail movements can create environmental pressures, including emissions, contamination, greenhouse gas emissions, and also impacts on surrounding communities. So this session is going to explore how dry bulk ports can move beyond reactive compliance to integrated, data-driven environmental management. For port authorities and policymakers, this discussion will provide practical insights into how environmental performance can directly support resilience, competitiveness, and access to capital. This webinar is the 6th in a series of webinars that aim to spotlight what ports around the world are doing to address some of these challenges and explore how their approaches can be adapted and applied across Southeast Asia. The webinar is organised by the ASEAN Catalytic Green Finance Facility, which is managed by the Green Finance Hub of ADB's Southeast Asia Regional Development Department. It is hosted by ADB's Southeast Asia Development Solutions platform, SEADS. Okay, so now I'd like to move on and introduce our great panel of speakers. We've got 4 speakers with us today, and I'd like to invite Nathan Jushaw to join us on the screen. So Nathan joined NCIG in 2007, and in his current role is Manager of Sustainability. Nathan is responsible for overseeing NCIG's, Newcastle Coal Infrastructure Group's sustainable business practices and relationship with the surrounding environment and the broader community. Nathan has over 30 years of experience in engineering, environmental and safety roles on projects in the Hunter Valley region and holds a degree in civil engineering and natural resource management, together with a master's in environmental engineering. So bringing a wealth of knowledge and expertise and experience to today's session. So thank you, Nathan, for joining us, and we'll look forward to hearing from you on your presentation shortly.
Thanks, Jackie.
Next, I'd like to invite Jason Wanga. Jason is the General Manager of DSH Systems. So if you'd like to join us on the screen, Jason. Jason is a global leader in passive dust control loading systems for bulk material handling. Jason's career spans technical sales and leadership roles across the electrical, renewable energy and gas industries. Jason brings extensive experience in industrial operations and environmental solutions. So very much looking forward to understanding DSH systems and solutions today and your presentation, Jason. So thank you very much for joining us this afternoon. We'll hear from you shortly.
Thank you, Jackie.
Thanks, Jason. Next up, I'd like to invite Rebecca to the screen to join us. So Rebecca is Manager Environment at Fremantle Ports, located in Western Australia. In Rebecca's role, she's focused on issues such as marine environmental protection, regulatory compliance, decarbonisation, and embedding circular economy principles. Rebecca is passionate about bringing relevant stakeholders together and sharing knowledge to collaborate on innovative solutions. And we're very much looking forward to your collaboration with us this afternoon, Rebecca, as you share some of the experiences from Fremantle Ports. So thanks for joining us today.
Great, thank you.
Thanks, Beck. And last but very not least, we have Rafizal. Rafizal has over 20 years of experience in the conventional terminal operations and currently serves as the General Manager of the Bulk and Break Bulk Terminal at Johor Port Berhad. Rafizal oversees the planning and execution of cargo handling operations for liquid bulk, dry bulk and break bulk cargoes and brings a wealth of experience in this field. We're very much looking forward to your presentation this afternoon, Rafizal. So thank you so much for taking the time to join us.
Thank you, Jackie.
Okay, so without further ado, I'd like to invite Nathan Jushaw back as our first speaker and hand the reins over to you, Nathan. So please feel free to take the screen.
Thank you. Appreciate the opportunity to come and talk about NCIG and the things that we do in this space. I guess to kick off the series, I'd like to just run through a high-level overview of the environmental management we undertake at NCIG, and the things that we piece together to make sure it's a comprehensive approach that's taken. So I thought I'd kick off with a little bit of background about NCIG. We are a coal export terminal. We're based in the Newcastle port in Australia, Newcastle, Australia. We operated a approval capacity of 79 million tonnes per annum, but our real purpose is driven by providing a long-term reliable service to our customers. So managing environmental aspects are key to this, as it means we can sustainably provide that service. Just quickly, the site itself, a single site operation, which simplifies things. What does complicate this environmentally is we handle high volumes at high rates of product movement, together with close proximity to industrial neighbours, commercial and residential neighbours. As you can see from the photo, we're adjacent and we're on a river, as most ports are, of course. We're also close to internationally significant wetlands. So this adds a layer of complexity to how we manage the site, and then a layer of obligation. Really governs that statutory and governance environment, and consequently drives those control measures required in that space. When we look at what that means, we operate under strict legislation and environmental approvals framework. And like I said, it governs what we do and our obligations. Our primary instruments are at state and Commonwealth level, and you can see that those instruments there on the screen, and the regulators that enforce those are also a key stakeholder group, which we need to service and satisfy through what we do. How we do that on site, the usual way, I guess, is we have management plans. They document the way we manage activities, and the controls are in place and translate a complex set of statutory requirements, legislation, approval documents, and the like into language and systems that our people can understand, so we can deliver on those obligations. That governance really gives us a clear direction on the key risks and controls that we need to put in place, the mitigating risks. The risks, you can see the primary risks are no different for us than a lot of sites, dominated by sort of air quality, water management and noise, which are more likely to impact on a wider community or stakeholder area. But more niche things like our spontaneous combustion controls, resources management, and controls in that ecological space are also need clear definition and delivery on site. What's true here is anywhere else. The increasing frequency of extreme weather events is also making that increasingly important we get these things right. I'll probably start with and provide most detail around our dust management system being one of our key environmental risks, and you might hear a bit more about dust as we move through the presentations, but we really act on an integrated system with a number of different aspects which are needed to account for that dynamic nature of the risk. Weather events, changing product types, these sort of things all need to be handled by this integrated system. It's really founded on sort of plant design, that inherent design features, that's infrastructure arrangement, primary controls. Operations obviously play a huge part, the handling of the product, how that we account for conditions and placement locations. Inline moisture monitoring really gives us that baseline of what we need to work off, gives us the start of our risk profiling for different product types. But the real noticeable part of us is that automated dust suppression system. It works on weather data, very data-driven system, both real-time weather and also on forecast weather systems. And that is very reactionary. As conditions change, the controls change as well from, it's a greater application of water or even slowing things down, changing the way those controls are applied. And the weather forecasting gives us a chance to get in front of weather systems which may causes an issue. Things like pre-wetting stockpiles, or as you see there in the photo, manual veneering. And monitoring and alerting networks are a compliance requirement, but also gives us a heads up when things aren't going well. We've got operational type monitoring around the site and compliance within the community, and allows us to, on the run, adjust controls, make adjustments to operations, and means we stay within the bounds that are set for us. Range of other risks I outlined there previously, and there's a network of controls, as you appreciate, in amongst all those. I won't go into a lot of details. A lot of things are routine here, but when I look at stormwater infrastructure as a way of managing that surface water risk, it's important you get that right and you're mindful of your conditions and those changing conditions as it comes to extreme rainfall and the like. And noise is a lot about monitoring, but also that constantly keeping on top of your equipment integrity or the condition of the equipment becomes a very difficult problem if it gets away from you. Routine groundwater monitoring is something we do regularly. Spontaneous combustion is an important risk we manage at NCIG. You may or may not be aware that coal self-heats and there's a tendency to heat to the point of ignition. So we do a lot of temperature monitoring from a automated and routine basis and manage our residency of those coal piles. You can sort of see an image that reflects that. Resources management. Recent addition for us is the introduction of a recycled water stream. We're really conscious in Australia of drought conditions, and as those conditions start to apply restrictions to community, it's important that we feel as a business we don't heighten that. So we're at the point now where greater than 90% of our water is either recycled water or captured on site, which is a big change from years ago. So that's been a big change in the water security space, but also social equity space. Waste mitigation, segregation, also critical habitat management. As I said, we're close to critical wetlands, and NCIG manages as a partially an obligation for compensatory habitat, but also the habitat for two endangered species, being an amphibian and a bird species, is managed actively by NCIG. So that's kind of it when we look at risks around in the environmental space. It's also important that we manage and provide guidance to stakeholders, their expectations, but also let them understand what NCIG finds important and what's important to us. And how they understand that is primarily through our sustainability strategy. You can see from our strategy there, it's founded on, I guess it started out with our customers' requirements and staying sort of attentive and flexible to that. Also a strong governance and compliance basis where a lot of this information and controls that I've just talked about fits into. But the above compliance side of things is kind of what is captured here. You can see in the area we're talking about now is a plant and environment space. We make sure that we're very clear on what that means. So again, our people can understand, but also our stakeholders can understand. So clearly articulating those goals and particularly targets, so that we hold ourselves to account and we can also be challenged on is that comparable with expectations, community standards, social standards. So this is something that's we've seen see a large uptick in appreciation from our stakeholders and understanding of what NCIG is all about. And you can see some of those things translate from what I was talking about before. And we really demonstrate that commitment through our transparency. it's great if you're doing good work. It's even better if you do good work and people know about it. So again, getting out there those stated commitments, what that means, the level you want to achieve, and then demonstrating your performance and being very transparent around that. So that looks like for us a website, management approach documents which lay out obligations and commitments, policy suites, performance reporting, being very transparent around that, sustainability and compliance reporting. They're different and they've got a different tone, but certainly making those available, and then the background data, which helps people see those trends and be really transparent around good and performance which is might be below par, and you need to demonstrate that you own that and you're prepared to continue to work to strive towards what you set out to achieve. So, Jackie, thank you. That's all I had for today. So happy to hand it over.
Nathan, that was fantastic, and thank you so much. And I think it's a really fantastic demonstration of how things are done well. And I've certainly had the benefit of visiting your facility, and I can verify that it certainly is done well. Really appreciate that presentation. We'd love to invite you back for Q&A at the end of the session. I've certainly jotted down a few questions, and I'm sure the audience have some as well. So audience members, if you do have questions for any of our panelists, please do feel free to use the Q&A chat function, and we'll start to see those coming through, and we'll be able to respond to those towards the end of our session. But Nathan, thank you so much. I really appreciate that. So next I'd like to invite to join me on the screen is Jason. So if you can pop your camera on, Jason, and I'll hand the reins over to you to share your presentation this afternoon. Thank you.
Thank you, Jackie, and thank you, Nathan, for the excellent presentation there. I learnt quite a bit. So hi, I'm Jason Farnger, General Manager of DSH Systems, and we're a New Zealand provider of passive dust control technology. DSH has sold over 10,000 units installed in 74 countries around the world. We work with a range of materials, aggregates, grains, fertilizers, salt, sugar, wood pellets, and we work with most of the largest corporate companies loading bulk materials in the world. And when we work with products as far as we're loading, we try and reduce the dust by up to 96%. When we do that, we can protect the product, clean our operating conditions. We load denser and heavier, reduce maintenance and reducing cost. And we try and improve the working conditions. And I'm here to speak about dust. As Nathan alluded to earlier, there's a number of factors with dust that are problematic. It can be flammable, explosive, a neighbourhood nuisance, issues from local environment, health risks, maintenance issues, and it's a contaminant to waterways. As far as explosions go, I had the pleasure of going to this site in the UK. Around about 2020, they had a explosion that blew the top off 50 silos at the site. And the cost of the remediation from this risk, this explosion, was significant. And I looked at the infrastructure they put in after the fact, and it's so big that by reducing the dust before this happens definitely reduces your risk. This is another site. They had issues with the neighbours that were complaining about the dust from across the other side of the harbour. They had a standard telescopic chute loading fertiliser into the ship, and they were told to sort it out, otherwise they would close the port. The cheapest and easiest way was they communicated with us, and you can see quite a big difference from before and after. Unfortunately, our system will work with most products, but unfortunately, coal, Nathan, isn't one of them. And the other ones is like flours or powdery products. So one thing is, if you reduce the dust, you reduce things like cleaning, you reduce the maintenance. And this is a site in China. They manufacture soybean oil, and they installed a number of systems, including our hoppers here, and they reported to me that they reduced the cleaning by 60% and their maintenance at the same time within these areas of the plant reduced by 40%. So with DSH, one of the key things for us is to work through our design criteria for passive dust reduction for equipment. First of all, we've got to understand the reasons why the dust is being generated in the first place. And then we decide, can we passively manipulate it either through our hopper or through some other company's technology, and we can help our customers find that product. And can you passively manipulate the environment? And that's around something like, can we put something in the way to stop the wind coming through, close the door, those sorts of things. From those, that criteria, then we use our fundamental design principles to design or sort out a product for the customers. From controlling the material to control the dust, and I'll talk about that shortly. Keep the dust within the product stream, which is containing it. Reduce the number and size of weak transfer shapes, and I'll talk about that shortly as well. And keep your technology simple and smart, and design the solution for each application and material, not just something that you get out of the box and you hope it works. So this is our hopper. DSH hoppers control the material from the entry where it is to where it is stationary in the pile. We backfill the hopper to take the air out of the material as it enters the hopper, and it discharges in a solid heavy column. That solid heavy column keeps the dust inside, and as it enters the pile below, it fills the pile up from it within, keeping the dust contained. The shape of material is the key thing. With our hopper, we create a circular round stream of a column of material that falls through the air up to 30 meters, and it drives into the pile below. Now, shapes of material have a big impact on how you can control the dust. If it's a weak shape like the half moon or what you see coming off a conveyor, it will aerate very quickly. And an aerate product will fall through the air down into the pile below, and it'll slide across the surface or ricochet, creating dust. This is wood pellets loading at 600 tons per hour, and that is falling 30 meters. So in some applications with some products, you can get very good results by controlling the product through technologies like ours or other technologies. Other technologies include these product transitions like in the video here. This is a compressing deflector, and we control the direction of material and the speed and shape that it flows from the discharge of the conveyor, so that we compress it to keep the shape in a good strong shape, so that it reduces the time that it aerates. And that way we control it to a point where we can take it into our hopper, or it can go to another conveyor, or those sorts of applications. So when we come to design solutions, our key criteria is understanding, what are we loading? What's the material, whether it's an aggregate or it could be wheat or it could be a bran, and how are you loading it, and the technologies, and can we do something, or someone else's technology can do something to stop the dust. And we may integrate a number of technologies together that we know of, or talk to our clients about ways that they can do it to stop the dust. This is a port loading site in Vietnam. We engaged with them in 2019, I think, and we load things from ship loaders to truck loaders to warehouses, and we had to deal with lots of different things like wind, applications like this bulk store, and even the ship unloaders. And what we found is we had to design every solution to fit that particular application. So you can see here, prior to us installing this hopper, it was extremely dusty. And this is post the installation. And you can see in the next shot that you can see a significant difference. And there went through and changed most of them. So the customer was very satisfied, and I think we've got almost 20 units at this site. This is our latest solution. This is a grain terminal in Quebec. We were asked to provide a solution for them. It was a very tricky solution because they needed a unit that could be tilted. The unit must not overfill, otherwise you've got weight issues of material going up the chute. We also had to design an overflow and quite a number of different factors. So we came up with this unit here, and you'll see in a second that one of the issues we had to contend with is there was a batch weigher, and you can see that the flow changes for a second and then it starts back up again. So we had to take those pulses. So when you design something for a site, you've got to work around those things. Here's the safety blowout under test. We also develop things like trimmers. And this is a project that we're doing for an Australian port. And we're also doing one for a USA port that's quite different. This is a hopper at the top of the chute that I showed you in China. And we can develop things for crane stackers, variety of materials. And the good thing about this, it reduces the wind and requirements for filtration. As well as that, we have partnerships with companies around the world, like these baffle systems. This is an Australian baffle making system. And how baffle systems work is they stop the air from displacing from around the area, so that when you dump a pile of product there, instead of the air rushing away carrying all the dust, it's trapped that air within underneath the baffles, and the product flows through with significant dust reduction. And this is another technology that we work with. This is our hopper underneath a unloading silo. So when you integrate a baffle system and our hopper, you'll get significant dust reduction. And with conveying, we have a number of technologies where we can shape the material to stop the dust. So instead of it being in an uncontrolled fashion, it's under control. And where you can, we can help put you on to things like passive dust filtration, where you're changing the shape and there may be some dust there. And we've also designed a new head box for chutes to be able to integrate a few of these technologies, as well as our blowouts. And of course, you saw the misting systems and Nathan's chute systems before. We've actually integrated one with our hopper as well for an extremely dusty product, and they didn't want the overflow. So in conclusion, if you want to control the dust, control the material for as long as you can. Work with the environment that you're in. Don't try and fight it. Design to the conditions, and you get better outcomes for you and your local environment if you work to those kind of standards. And thank you.
Thank you, Jason, so much. That was a fantastic presentation, and it was really great to get some insights into the different solutions that are out there that can be applied to existing infrastructure, but also, new infrastructure that can be put in place to manage some of these dust issues. And I think, just really learning and understanding about the shapes and thinking about the different types of materials and the environments that, ports are operating in, it being critical to kind of finding the right solution. So thank you so much, Jason. That was fantastic. We'd like to invite you back at the end to join us for Q&A. But in the meantime, if anyone does have any questions that they want to start sending through, please don't hesitate to put those in the Q&A box. I can see one that's popped up there already. So please do continue to bring those questions through, and we'll get round to them at the end. Fantastic presentation. Thanks, Jason. So next up, I'd like to invite Rebecca James from Fremantle Ports to join us on the screen. Hi, Beck. Thanks so much. So we'll hand the reins over to yourself next to take us through your presentation based on your ports experience. So over to you, Beck.
Great, thank you, Jackie. And what a wonderful opportunity to be part of this great webinar series and hearing some of that fantastic transfer of information from the first two speakers has been really great. So thank you. I'll jump straight into my presentation. So I'm going to be specifically talking about the use of a specific piece of infrastructure to manage environmental issues, and that's the use of a CWTL enclosed unloader at our operations. Next slide, thanks. So I'm in Fremantle or Walyulup in Western Australia, which is land of the Wadjuk people of the Noongar Nation. So I'd just like to pay my respects to their elders past and present. Thank you. So a little bit about Fremantle Ports. So we're a port that's owned by the government. So we're a government trading enterprise that acts commercially, and then the profits benefit the state. So we have three main sites. So the top green one there in Fremantle is where it's our container port, where we handle most of the container trade for the state and vehicles and crews. And then two bulk handling sites down in Kwinana, where we handle the critical commodities for the state, such as fuels and building materials and fertilisers. So as a government trading enterprise, we've got some statutory functions under our Western Australian Port Authorities Act, and they're to facilitate trade and plan for future growth and development of the port, be responsible for the safe and efficient operation of the port, and a responsibility to protect the environment and minimise our impact of port on that environment. Thank you. Next slide. So down in Kwinana, Fremantle Ports has two sites. So the second one there, the Kwinana Bulk Terminal, is one of our bulk loading and unloading facilities. And then further south, we have Kwinana Bulk Jetty. And the three other jetties that are there in Cockburn Sound are private ports, so tenants of ours. So we have Alcoa, BP and CBH Grain Jetty as part of that as well. I'm showing this slide because I guess Cockburn Sound and where we're situated with those bulk handling facilities is an area that has really important environmental values and benthic habitats. It's also a really prized commercial and recreational fishery and really high social values. So a loved area for boating and diving and other recreational activities. So that's kind of frames the environment that we're working in these facilities. Thank you. Next slide. So the facility that I'll be talking about today is the Kwinana Bulk Jetty, where we have our CWTL unloader. And this is mainly an import facility, and we have third-party stevedores that are undertaking the unloading for us. And there's two berths at this jetty that accommodate bulk products such as fertilisers, sulphur, ammonium nitrate, and we have liquid bulk commodities, petroleum, liquid fertilisers, bitumen, etc. Next slide, thanks. So at Kwinana Bulk Jetty, we've got Australia's, where it was the first CWTL that was put in operation in Australia back in 2001. And one of the main drivers for that was that location of Cockburn Sound in which we're operating. So the CWTL that we've got can unload cargo or sulphur at 1,200 tonnes per hour. And it includes also an inbuilt fire suppression system, which is important for sulphur. Like other bulk handling facilities in Australia, our activities on site are very heavily regulated, and we've got licence under our State Department of Water and Environmental Regulation. Next slide, thank you. So look, I must apologise for the quality of the photos here. I did have a video and it really was too large and unwieldy to be able to share it properly in a webinar. So I've taken some screenshots that are a little bit blurry, but I hope that I can get that picture across as well. And this photo first is just to show you the cab of the Seawatel, and that's an operator sitting there operating the machinery. And this next slide here is the Seawatel inlet feeder. So the sulphur is picked up from below the cargo surface by a counter-rotating head. So it feeds material into the vertical screw in a continuous unloading fashion. It did look much better on video, but hopefully you can get the picture there. And this is the Seawatel from the outside. So often you really can't tell that operations are occurring due to that lack of dust and spillage that can often be associated with some of the traditional grab unloaders and other methods. So yeah, just on the other one, sorry, back on the other slide, the bulk material transfers from the vertical conveyors onto the horizontal conveyors, and the material drops through enclosed gantries that have their own dust filters and then leading onto the conveyors. Thanks. And yeah, you're showing those conveyors in the next slide there, where there's then fully enclosed conveyors that have come down, and from the jetty net, these are then leading into the landside shed on shore. So the next photo shows then the fully enclosed system that's created by the Seawatel and the conveyors, then leading in and it dropping down from the shed straight into the sulphur shed. So some of the main environmental benefits from a system like this is that really there's near zero dust emissions in the outside environment. So as I said, they're fully enclosed from the ship hold to the shore conveyors. It means that dust isn't escaping into the air during unloading, and eliminates the need for water sprays, large dust suppression systems and dust monitoring networks. And there's no spillage either into the water or onto the berth. So this can obviously prevent cargo entering the harbour or contaminating the berth side. So avoiding both that contamination, but also costly berth cleanups and loss of products. And because it operates with that continuous screw mechanism, it results in a 30 to 50% lower energy use than traditional grab unloaders. So obviously much more efficient from a greenhouse gas emissions perspective per tonne handled. So why does this matter? So for those of us that are in the environment game, and those of us that just understand the importance of this, the big thing is that it protects our air and marine quality around ports. For our social licence to operate, this also makes the community much happier and reduces those complaints, and gives us a reputation that allows us to build and continue to grow on those port operations. So when we put the Seawatel in, this was a big plus in terms of getting more streamlined environmental approval, and compared to the dust and spillage and other monitoring conditions that we have for our bulk loading and unloading sites, this is really very simple and makes my life as an environmental manager much easier. It improves the work health and safety environment for our workers on site, and helps achieve organisations' sustainability goals and those emission reduction targets that most of us are all working to in today's world. Thanks. Next slide. So still in Australia, bulk ports are dominated by grab cranes. So this is my understanding, and there may be others on the call that might have other information of where the Seawatels are that are operating in Australia. So we have ours for sulphur in Kwinana, and we have another unloader in Adelaide for cement. There's also a couple of mobile Seawatel unloaders kicking around some of the ports, I understand, that can be moved for multi-port use. And then we have 3 loaders in Newcastle, Whyalla and Adelaide with different products there. So why, I guess, with all those benefits, wouldn't everybody be using a Seawatel for every operation? Well, there are definitely considerations to where this type of infrastructure can be used, and one of them is the high capital costs. So Seawatels are significantly more expensive than traditional grab crane systems, and part of that is that they require all this purpose-built infrastructure and enclosed specialised conveyors and inbuilt dust control systems that all come with it. There is some limited cargo flexibility, so it's not for every port. You need to look at what your port products are and whether this is suitable. So Seawatels can struggle with large, lumpy material or sticky or highly cohesive cargo. And some of that really abrasive bulk cargo is not necessarily suitable. So in general, it tends to be not as suitable for multi-cargo ports that are handling varied commodities and very suitable for when you have a specific one, for instance, with the sulphur at Kwinana Bulk Jetty. And because they are more mechanically complex and they do require specialised maintenance compared to the really simple grab cranes, which are a lot simpler and sometimes easier to repair locally. Thank you. That's me, and I have got questions there, but we'll save those for the Q&A. Thank you, Jackie.
No problem. Thanks ever so much, Beck. I really appreciate that. And again, similar to Jason's presentation, it's really about thinking about the nature of the material that you're looking to handle and finding the right solution. And as it relates to the Seawatel, more kind of a dedicated commodity, rather than that kind of multi-cargo function. But that was really, really fantastic to hear your presentation today. Beck, we'd like to invite you back for Q&A at the end. So we do have I've got a couple of questions as well that I've noted down for you. And hopefully if the audience have any additional ones, we'll bring those to the table as well. But yeah, really appreciate your time for that presentation. Thank you so much. And our final presenter today, I'd like to invite Rafizal from the Port of Johor to join us on the screen, who will lead us through his presentation. So thank you very much. Over to you.
All right, thank you, Jackie. My name is Muhammad Rafizal. Good morning, good afternoon, everyone. I'm the head of department for Bulk and Bulk Terminal in Johor Port Berhad. Today, I would like to share some practical insight on how we manage dust, runoff, and also emissions based on our day-to-day experience on the ground. So let's begin. Let me introduce my port first. Okay, Johor Port is located in Pasir Gudang, Johor. We are operated as a multi-purpose port, serving as a gateway in the southern region in Malaysia. We are part of MMSC Group. As of today, Johor Port, we position ourselves as a regional commodity hub, particularly for cargo. We are one of the largest palm oil terminal, and we are also among the largest handling port of fertilizer in Malaysia. Next slide, please. Okay, within Johor Port, the conventional operation actually managed under my department. We call it Bulk and Breakbulk Terminal, or in simply word, BBT. We handling a wide range of cargo, including dry bulk, liquid bulk, and also breakbulk. So our operation cover the full range cycle from vessel activities, loading and discharging, to the yard handling, storage, and also inland transfer. Because of the nature of the cargo, the operation are generally using more conventional method, which require close operational control. Next slide, please. Okay, as a brief, bulk and breakbulk operation, our terminal have an annual capacity of up to 7 million tons. We are supported by dedicated 4 berths with 7 key cranes and integrated conveyor system designed to ensure safe and efficient cargo handling. For the last few years, the dry bulk continue to be our major contributor to our overall throughputs. but due to the nature of dry bulk cargo, there are potential environmental risks, particularly related to the dust generation, runoff, and also emission. Next slide, please. Okay, let's move to the main topic today. Dust control is one of the most important environmental focus area in our terminal. Johor Port actually handle 1.4, not yet. Okay. Johor Port actually handle about 1.4 million tons of clinker, 1.3 million tons of cereals, and about 1 million tons of fertilizer and minerals. All this cargo are dusty and surely very sensitive to the weather. Next slide, please. Okay, why this matter? Dry bulk operation are naturally exposed to environmental risks. So this is mainly because due to our operation are very open handling activities. There are multiple transfer points. We also depend heavily on equipment, very conventional equipment, and all this cargo are very sensitive cargo and also sensitive to the weather. From our experience, the main concern falls into three areas. We focus on dust and runoff, where the cargo residue can be carried away by the rainwater. And also the third one is emission, mainly from our machinery and also from our vehicles. Okay. Among these three, I would say that the most immediate day-to-day challenges in dry bulk operation is dust management. For BBT, we have two mode of cargo transfer. We can transfer the cargo from wharf to the warehouse or to the consignee premises using either a fully conveyor system, or we also can transfer the cargo using conventional mode, whereby we use tipper trucks. So far, dust management is one of the key control. One of the key control we use for the dust management is we using a hopper with the duster system. When the cargo release from the grabs into the hopper, there will definitely be cargo dust flying around. So this duster will help to capture the dust and keep it from spreading into the air. Actually, it is ideal if we can fully utilize our conveyor system. But in some cases, our consignee or cargo receiver, they do not have these facilities. So we still need to use the conveyor mode, which we're using the triple trucks. So we focus on controlling the cargo, not yet. Okay. Maintain this slide. Okay, we still manage. We are focusing on the controlling the cargo drops. Means that when the crane operator open the grabs and we want to make sure the cargo properly put into the hopper, the grab must be the grab must be placed as close as possible to the hopper. So this will avoid dust pollution. So our operation supervisor will supervise the crane operator to make sure they follow this rule. So for overall, dust control is a combine of equipment and also operational discipline. Next. Okay. We go to runoff. Runoff is slightly different and it's more challenging. The main concern is when the cargo spillage happen during operation. The cargo spillage on the ground, especially on the water surface, it is easily can be carried away by the rainwater. So how we manage this? We actually focus on preventing spillage in the first place. Some of the measurements we apply includes deploying loading bins. This actually loading bins limit the truck drivers when he want to dump the cargo dump the cargo, tipping the cargo from their tipper trucks. They only can tip into a specific area. So by practicing this, we can eliminate from the cargo, we can minimize the cargo spillage. We also practice to cover the loading bin using the tarpaulin to avoid the cargo contamination, especially during raining. This also will avoid them to be carried out to the sea. At Johor Port, we have a facilities, we call it port reception facilities. So by having these facilities, actually we can dispose the wastewater through the industrial effluent treatment system, we call it IETS. This is the initiative from our top management to ensure that we can control the how we dispose the wastewater. So the key here is we have to control at the source, prevent spillage, not just relying on the infrastructure. Next page, please. Okay, for emission, the main source are our equipment and also our trucks lah. Our approach is quite practical. We focus on improving practical operational efficiency. For example, we now introducing unmanned vibration system. With this system, actually we can reduce trucks waiting time from 5 minutes to 30 seconds. So we implement also idle zone and off engine practice. We also optimize trucks route to minimize unnecessary movement. All these arrangements actually to ensure lesser fuel being burned by the machinery or by the vehicle. In addition, we plan our equipment deployment more effectively by using just-in-time approach. Means that we only apply our excavator when it being really needed for the cargo to be grabbed by the crane operator. So in many cases, reducing emission actually started by reducing inefficiency, by reduced amount of fuel consumption, and also this will directly translate into lower emissions, which ultimately benefit to our environment. Next slide, please. Okay, of course, it is really not easy practice. So different cargo behave differently. Some are dustier, some are more sensitive. At this time, we need to balance between productivity and also the environmental control. So there were also limitations in terms of space, infrastructure. Of course, some investment need to be invest, but most important is it's not something that port can do alone. We need to have a commitment also from other port user. The port user, contractor, transporter, and also the cargo owner. Okay, as a conclusion, driver operation at BBT will always come with the challenges and not. This is not a straightforward operation. From our experience, this can be managed better when environmental control is treated as a part of daily operation and not something separate. So the fundamental are good planning, proper supervision, good housekeeping, disciplines, and also continuous monitoring. So ultimately, the most effective approach to prevent a spillage at source. So without this spillage, so actually we can control these three, the three items that we discussed earlier. At Johor Port, we focus on control practice, practical supervision, and also continuous improvement. My last word, cleaner operation begin with better operation controls. With that, I would like to conclude my presentation. Thank you for your kind attention and look forward to the discussion.
Rafizal, thank you so much for that presentation. And I think one of the really important messages there for me was it's not just about the kind of infrastructure and equipment that you have on site, but it's also about some of those kind of changes to how you operate, like the just-in-time arrival, the reduced idling time, and things like that. That can all kind of collectively contribute to these better outcomes. So yeah, no, thank you so much for that presentation. It was really, really informative, and there was a few new kind of techniques that I hadn't come across before that I thought were really valuable. So thank you so much for that. We have just a few minutes left, so I'd like to invite all of our speakers, or you can stay on the screen as well, Rafizal, back to join me on the screen, and we'll just have a short Q&A session. Awesome. So thank you, everyone. I think there's some really interesting knowledge shares there. And like I said, I've certainly learned a lot today, and hopefully our audience and each of us has taken something home too. We do just have one question, and I'm not sure who wants to take it, if anyone, but I know you've all had a chance to look at it for a minute or two. So there is a question here, just obviously we've talked about kind of dust that's arising from the commodities that we're handling and the different kind of types and nature of each of those. But also, what's being raised is dust that's generated from tires, kind of with heavy vehicles operating on sites. And obviously, they can create a dust and a kind of contaminant in their own right. Has anyone got any thoughts on any sort of suggestions on how you would address, I guess, dust fallout from other sources that might not be the main commodity on your operational sites?
I'll jump in and give it a crack. Jackie, we don't deal with this issue. We don't have a lot of trucks on site, but I think Fazal hit the answer on the head. It's about good housekeeping. You just got to keep on top of these things. We have a lot of coal on site that we need to control. We try to minimise spillage through good operational practices. So keeping on top of that, having good systems that so if you think about stormwater, you don't shedding stormwater off site with contaminants, but certainly keeping on top of any accumulation of this product, which then becomes available to be windblown and emitted from the site is key.
Yeah, absolutely. And I think it's all about that kind of minimization at the source in the first place, but then that control on the site and housekeeping and kind of managing that stormwater runoff, even if through a kind of first flush or something like that is a great way of doing it. We've probably got time for one more question. We've had amazing presentations, so we don't have a huge amount of time for Q&A. There's nothing else coming through on the chat, so I might just open up a question, and again, someone can pop their hand up if they want to answer it. But we talked about kind of third-party operators on site, so obviously that's I guess a degree of direct kind of operational control removed from port operators. How do you manage and oversee stevedores and other operators on site as a kind of port authority? Maybe it's more kind of aimed towards Rebecca and Rafizal in that regard, to make sure that they're meeting your requirements.
Yeah, I guess I'm happy to jump in, because this is a significant issue for us. So we hold the environmental license at our bulk handling facilities, and then the performance of the third-party stevedores then comes down to us under our license. So we've been very deliberate in creating our own internal berth handling standards and environmental standards that are required on the berth. So now when we're contracting those stevedores, they're very aware of those obligations that we're contractually binding them to. And more than I guess we would traditionally in some of our other port operations, we're very hands-on with specific dedicated staff doing inspections to make sure that's being undertaken in the manner in accordance with those standards, and then holding the stevedores to account during that loading and on shift, and not waiting for them to blow out. So it has been a journey for us, and I think building the relationships with stevedores and having them get that understanding certainly helps along the way. But yes, it is tricky sometimes when you're the one that's liable and you have other operators working for you.
Yeah, absolutely. And I think that was a great response, Beck. And I think, as you mentioned, it's not just about kind of setting the rules out. It's really having that kind of oversight and those check-ins and most importantly, building those relationships with your stakeholders as it relates to managing those impacts. We are at time, but I would like to say thank you so much to our speakers today. There's certainly a lot to take away from this session in terms of the different types of commodities, how they behave, and how you need to understand those in order to manage them, but also how you can adjust your operations to further minimize those environmental impacts. So thank you so much to each and every one of you. We hope that you'll join us for our next webinar, which is coming up in May, and it's focused on future fuels and the energy transition. So in the meantime, thanks so much. Have a lovely afternoon, evening, wherever you are, and we look forward to seeing you next time.